Hello again and welcome to the second part of this destruction tutorial in Houdini and Unreal Engine. My name is Michael Rukowski, I'm the technical director at MetaMeow. And in this second part of the tutorial I'm going to show you how to import the Houdini data into Unreal Engine, how to work with Vertex Animated Textures, ensure performance is up to speed, and make sure that it also works with other static meshes and can be replaced in time for when we need destruction to happen. So without further ado, I've already opened up the template project, which is attached in the project files for this tutorial. I'm going to start bringing in the various caches that we created in Houdini. First of all, we should have a static mesh here that I will create inside our destruction folder. I'll create the meshes folder and simply import this in. For this static mesh, you have the freedom to use nanite or not. In my case, I'm not going to use nanite, but you are free to enable it if you need. And this will take a second. After that, we will end up with a static mesh that we can place in the scene and start building our other layers around it. So here is the non-destructible part of our building. At the moment, it does not have any materials, but the material slots are here. I've also provided some basic master materials which can be used to create your own material instances. So we can create one for concrete and glass. Now I'm not going to go much into the actual settings. I'll just assign them quickly so that we can go on and see the different layers in the building. Now one of them will be glass, and I'm just trying to find which one that is. That is actually the final material that will be glass. Okay, so now we have a static mesh, and I'm also going to start bringing in, I'm just going to save this quickly, and we can start bringing in the RBD part of our cache. So here we have the RBD as well as the debris mesh. I'm going to bring both of these in. In the FEX import settings, we're going to change a few settings to make it easier to work with VATs. First of all, we'll ignore vertex colors as we are not using them. Also, will not remove the generates, as this can mess up some of the data, the triangles that the VAT is using to capture information such as the bounding blocks of the simulation. Also, will not generate light maps or build buffers. All we need to leave is to transform vertices to absolute. We also import normals and tangents, convert the scene, and do not create materials. With these settings, I will hit import and give it a while to process. Now we have the RBD part of our mesh. We can see they are both in the same scale, which is fantastic. And I'm just going to offset these to be at the origin, which just makes it slightly easier to position. Okay, we have now aligned these two meshes, and I'm going to just assign the same materials. What's even better than doing it in the map is to assign these directly to the static meshes, which allows us to then reuse these materials whenever we need. And whenever we recreate the actor, it spawns with the right material assignments already. So we'll do this for this one, the static mesh as well as the RBD cache. So for this one, the glass is actually the second to last. Okay, and now what we have is a pretty nice looking building comprised of two parts. The first part is the static mesh. The second part will be our RBD simulation. This we can save the scene. And now I'm going to bring in the VAT textures which are necessary for the simulation to work. So go up one level and into the texture folder. For now I'm going to ignore the debris data as we'll bring it in the next step. Once these two textures are imported, we also need to make sure they are set up as these are EXR textures and they need to be uncompressed in memory in order for VAT to work. So I'm going to right click, go into scripted asset actions and select Houdini config files, config textures for VAT HDR. Once this happens, you can see that they are set to no MIPS and HDR, not compressed because compressed HDR messes with the data here, so we're not going to use it. This ensures that the pivot data, the position and rotation data for the RBD sim is kept in memory without introducing any bias. Okay, and based on this, we can now go in and create another variation of our materials, which uses VAT. Now using static switches, we're going to enable VAT, which if you want to create your own, all you need to do is to go into the material editor and search for VAT. So these material functions are provided by side effects, and in this tutorial we are using rigid body dynamics, which is this node here. Not all of these outputs need to be plugged in, but for reference you can go into this material function VAT, which is just a convenience method for reusing the rigid body dynamics node in a variety of master materials. In our case, we only needed to use the normals, the world position offset and the customized UVs for this to work. Also remember, if you are rolling in your own custom material without using this material function, remember in the master material the normals, tangent space normal needs to be disabled for this to work correctly. In the MI Concrete VAT version, we are going to go in and override the position and rotation textures and drag in the textures that we just imported. Based on this, if we have auto playback and our simulation is done in 24 FPS, we're going to use 24 FPS here. And this is all we need to do in order to start seeing our destruction. However, the reason we're not seeing is our VAT material is not yet assigned, so I will do it now. And you can see that as soon as I assign a material with VAT, we're starting to see our destruction in the viewport. You can still see some bits, such as the glass and pillars, not moving, and the reason for that is they have not been assigned the VAT textures yet. So we're going to create a variation of the glass material with VAT on, and using the exact same parameter overrides as the concrete. Now we can assign the glass material or the VAT version of it. Start to see glass moving together with our pieces. And finally we have the pillars which still don't move. So we can create a copy of this material, make the base color darker, my pillars VAT and assign it to our mesh here. Oh, I assigned the wrong part. So these are the pillars. And the second to last should be glass VAT. And now what we can see is all of the parts moving together. One thing you may notice is the movement is slightly clunky, and that's because of the FPS not being high enough. So what we can do in order to improve that is DAT 3.0 has a brilliant feature called interframe interpolation. The interframe interpolation allows VAT to read from two adjacent frames and interpolate the position. The next part that I'm going to do is I will bring in the debris part. So again, go back to meshes, import the debris mesh, and remember to check the advanced settings in the mesh rollout to make sure the settings are same as here. We will only need transform vertex to absolute. We will import normals and tangents, and do not create materials. While it's importing the debris mesh, we will also go in and import the textures. Again, go right-click, scripted asset actions, and then go Houdini config textures for VAT HDR. With this here, you can see the textures are nicely imported. For the debris, we're going to need another material instance. That's because we need to use assign different textures for the VAT. I'm going to drag in the debris, move it to the origin. And as you remember, we had to store our debris somewhere as a cache. This is the object pool of all the pieces which can be usable throughout the simulation. And they are just waiting here, sitting, waiting for the PopSim to drive them. And after assigning a material to these, and you can see that my assignments were not entirely correct, you can start to see the debris moving. At the moment, the movement seems fairly clunky and incorrect. And this is a common issue with VAT, is that the textures aren't loaded properly in the editor. So if you ever see strange artifacts like you may have seen just now, then make sure to go in and open the texture editors for both of your VAT textures and see if that helps fix the issue. Now looking at the debris, we know that the scale looks pretty wrong. The pieces are way too large, and I would like to fix that. There are two ways of doing that. One is to go back to Houdini and fix the simulation, VAT, and re-export, and one more through Unreal Engine materials, which I'm going to introduce now. So in the material instance settings, if you scroll down to Houdini VAT customization, there's a global piece scale multiplier parameter, which can be used to apply a scale very conveniently, change the size of every piece in the simulation. So try it with a multiplier of 0.5, gives a lot more believable results. Of course, this can be modified further. Something like 0.3 gives very fine results. However, mind you that at this scale of changes, you might see that the geometry no longer touches the ground as the positions are stored in a texture, which means they're getting further away from where they should collide and towards their centroid. Therefore, I'm going to keep it at 0.5, which is still reasonably accurate and gives us a much more pleasant result. In the final part of this video, I'm going to import the smoke and combine it with the rest of the building. So I'll create a new folder, call it volumes, and go find our cache, which should be under the geo folder, and call it smoke. Drag the first frame, which should be in VDB format, into Unreal, so we'll recognize it as a sequence, hopefully. And we can import it as either an 8-bit or a 16-bit float. For now, we'll just keep it at 8-bit. And now we end up with an animated sparse volume texture, which we can plug into a sparse volume material and use as a heterogeneous volume. For this, we'll need two items. First will be heterogeneous volume. This is an actor, which we can place at the origin, and we'll need a material instance to control all these other parameters. So I'll go into material instances, and I will create a material instance and call it mi smoke. And we'll need a material parent for this. And there is actually one pretty decent master material included in the engine content. Which, if we enable show engine content here, will show here as a sparse volume material. So we'll select that. And here in sparse volume textures, we'll select our animated texture here. Let's try and assign this and see what happens. So right now I cannot see anything. It's because playing and looping are both off. So take them on to see the result. And then hopefully you should be able to see the smoke. One thing that is obvious is that the scale is wrong. So first I'll scale it up, say 100 units. Now we can see it is much closer to what we wanted to see. However, there are some other issues, and first of all, the offset is not correct, so it is still not placed where the emission part is. Another problem is that the timing is off. So the smoke simulation and the RBT simulations are currently running at their own different timers. And we'll need some synchronization in order to see the entire effect. The final issue is that the smoke itself is right now very thick, perhaps too thick for the type of dust that we are looking to see in building destruction like this. For that, we might need to change the density a little bit, play around with albedo as well, until we see something reasonable. This looks a bit more like it. However, it is difficult to tell because of the other issues we are having, especially the timing issue. Right now, we are running all these separate components in different actors and using the materials for auto playback. However, in order to keep all of these timers in sync, it would make sense to create a blueprint actor, including all of these elements, and then use the blueprint to control the timer instead of letting all of them run at their separate timers. So in the blueprints folder, you will find a blueprint, which I've prepared already, and it contains several components. There are 3 static mesh components and 1 heterogeneous volume component. These are all hooked up on begin play to replace their material instances with dynamic material instances, which can then be controlled, and the timer is set on tick for every material instance dynamic that is created by this. So all we need to do is open up this building and fill in the static meshes, reconnect them with their respective static meshes from our import. And then the smoke will use its own material. Now with this set up, we can drag in the building. Since we have all of this already, I will temporarily disable the other static mesh building. In fact, I will go into the visibility and take that off so that we also don't see it during play. And now this blueprint only works in play mode, but instead of playing in, which can be a little bit distracting because of the mouse controls, I will use the simulate mode instead. So as soon as we hit simulate, we start seeing smoke simulating, which is a good sign. However, I cannot see the building destruction anymore. And that is because we need to untick auto playback and check the override for each layer. Okay. Now the destruction still doesn't work despite all of these settings. And that's because the material assessments are not the right ones. So we'll have to go back and reassign the right materials. The RBD will need VAT concrete assessment. And now we can see everything running all together. The number of frames can be controlled here in the cached frames. In this case, we cached 240 frames, so I'll input that. Looking at the result, what I'm thinking is the smoke appears and grows too quickly, and it dissipates too quickly as well. And one more thing I cannot see is debris, so let us go back and inspect what happened. Debris has no material instance assigned, so we'll assign it here. And now with all this setup done, we can see all of the layers working together to create a nice explosion effect. Looking at stat GPU, you can also see that the GPU cost of this simulation is also fairly low, with the most expensive item being the dust layer itself. This means we have a remaining budget to go back to Houdini and, for example, increase the number of pieces, fracture with more detail, create more clusters, or add more debris points to make the simulation more compelling, with maybe more size variation. We could also make the simulation longer, since our textures are still not using the entire size of a 2K texture. We still have some space to add more. After aligning all of our building elements in a blueprint, there's one more thing that needs to be fixed, and that is the smoke position. By default, heterogeneous volumes are not aligned with Houdini volumes, and so the VDB information needs some transforming in order to make it fit and aligned with the RBD simulations. For this, we are going to open up our blueprint and go to the smoke component. And as you can see in the transform section, I've rotated the volume by 90 degrees in the x-axis, as well as applied a -100 scale in aligning the values in the transform in this way, and also leaving pivot and centroid off. You will see that the smoke simulation is now aligned with the rest of the simulation, and the smoke appears where the pieces break, which is exactly as we imagined. And of course, this aligns with the way the smoke is emitted in Houdini. Based on this, we now have a complete simulation of the building. Of course, from here there are many ways to take it. We could add more pieces, we could make the geometry more complex, we could add more secondary simulations. For instance, we could take just the glass pieces and simulate them separately while respecting the clusters, but also adding overlapping animation. We could increase the number of pieces, we could also add more debris, we could make the smoke thicker or more dense. There are so many ways to make this destruction even more refined, and I'm very excited to see what you guys will come up with after watching this video, and opens up doors for all of you to experiment and create something great using game engines and Houdini. I hope you enjoyed this tutorial. If you have any questions, please leave them in the comment section or visit our website metamiao.com, get in touch, and we'll be happy to assist you. Thank you very much for your time, and hope you have a great day.